Good morning everyone. Today you will start sequence and series of function. आज हम लोग sequence and series of function पढ़ने वाले हैं और इस टॉपिक में हम लोग देखेंगे कि sequence of series of function कब पॉइंट वाइज कन्वर्जेंट होगा, कब यूनिफॉर्मली कन्वर्जेंट होगा। जैसे हम लोग sequence and series of रियल नंबर पढ़े थे, sequence and series of रियल नंबर में sequence कन्वर्जेंट हो सकता है, डाइवर्जेंट हो सकता है या ऑक्सिलेटरी हो सकता है। ऑक्सिलेटरी में दो केस, ऑक्सिलेटरी फिनेटली या ऑक्सिलेट इन्फिनेटली। इसी तरीके से सीरीज में हो सकता है, सीरीज कन्वर्जेंट, डाइवर्जेंट या ऑक्सिलेटरी। आज हम लोग पढ़ने वाले हैं सीक्वेंस एंड सीरीज ऑफ फंक्शन। सीक्वेंस मे बी पॉइंट वाइज कन्वर्जेंट, यूनिफॉर्मली कन्वर्जेंट, ये मे नॉट बी पॉइंट वाइज कन्वर्जेंट, मे नॉट बी यूनिफॉर्मली कन्वर्जेंट। एंड सीरीज मे बी पॉइंट वाइज कन्वर्जेंट, यूनिफॉर्मली कन्वर्जेंट या मे नॉट बी पॉइंट वाइज कन्वर्जेंट, मे नॉट बी यूनिफॉर्मली कन्वर्जेंट। तो आज हम लोग इस टॉपिक के बारे में डिस्कस करेंगे। चलिए अब हम लोग स्टार्ट करते हैं टॉपिक। और लेट D is a non-empty subsets of R and Fn is a function from D to R. D is a non-empty subsets of R and Fn is a function from D to R for all n belongs to natural number, such that image of x is goes to Fnx. Okay. For any fixed x belongs to D, sequence Fnx n equal to 1 to infinity is a sequence of real number, is a sequence of real number. Let Fn is a function from 0 to 1 to R and Fn is defined as Fnx equal to t to the power n t, okay, t to the power n बटे n factorial for all n belongs to natural number, for all t belongs to close interval 0, 1. This is a sequence of function Fn t equal to t to the power n factorial is a sequence of function. If you take t equal to 0, then Fn t equal to 0, which is a sequence of real number, also known as the zero sequence, but this is a sequence of real number. If you put fixed point of t is equal to 0, then sequence of function convert into the sequence of real number. Sequence Fn 0 n equal to 1 to infinity is a sequence of real number, sequence of real number. If you put t equal to 1 by 2, Fn 1 by 2 equal to 1 bata 2 to the power n, 2 to the power n into n factorial. This is sequence of real number. This is sequence of real number. Fn 1 by 2 equal to, this is 1 by 2 to the power n into n factorial, n equal to 1 to infinity. This is a sequence of real number. That means note t belongs to close interval 0, 1, then this sequence f of f1 t naught, f2 t naught, fn t naught. This is sequence of real number. Is a sequence of real number. If there exists, now we define when we say sequence fn is convergent. We already studied sequence and series of function of real sequence and series of real number, and आप लोग देखे थे कि sequence के पास तीन तरह का प्रॉपर्टी हो सकता है, चाहे तो कन्वर्जेंट हो सकता है sequence of real number, वो कन्वर्ज कर सकता है या कन्वर्ज नहीं कर सकता है. कन्वर्ज नहीं कर सकता है तो उस केस में दो केस अराइज होता है. फर्स्ट केस चाहे तो ऑक्सीलेट करेगा या डाइवर्ज करेगा, और ऑक्सीलेट भी दो तरीका का होता है, चाहे तो वो फिनिटली ऑक्सीलेट करेगा या इनफिनिटली ऑक्सीलेट करेगा. तो बट इन सीक्वेंस एंड सीरीज ऑफ फंक्शन two type of convergence, one is pointwise convergence and another is a uniform convergence. Now we defined when we say sequence is pointwise convergent. Okay, if there exists LT naught belongs to real number, this number belongs to real number such that for any epsilon positive there exists n epsilon t, n depends on epsilon and t naught, such that mode of fn t naught minus LT naught less than epsilon, mode of fn t naught and LT naught less than epsilon for all n belongs to natural number, for all n greater than equal to n naught and depends on the epsilon and t naught. Then we say sequence f and t is pointwise convergent. Pointwise convergent at t naught, only t naught, not in d. That means limit of n tending to infinity fn t naught equal to LT naught, only at t naught, x is equal to t naught, t is equal to t naught, this sequence is convergent. That means the sequence of function f and t converge at t is equal to t naught belongs to d. This sequence convergent at t naught. Now we define, now see the one example, okay, and then see the next concept. Example, let fn t equal to minus 1 to the power n t to the power n. for all n belongs to, for all t belongs to close interval 0, 2, and for all n belongs to natural number. At t is equal to 0, what happen? At t equal to 0, sequence fn0 equal to 0. fn0 equal to, this is a 0 sequence, n is equal to 1 to infinity, n equal to 0, 0, so on. This is converging to 0. At t is equal to 1 by 2, at t is equal to 1 by 2, fn t equal to minus 1 to the power n into 1 bata 2 to the power n. Sequence fn 1 by 2 is converging to 0. T is equal to 1, t equal to 1, then fn t equal to minus 1 to the power n into 1, that means minus 1 to the power n. Sequence fn t fn1 is not convergent. Why? Because we have already studied in sequence and series of function, sequence of real number. If sequence has two limit point, then sequence is not convergent. और इस sequence में fn1 equal to minus 1 to the power n. It has two limit point, 1 and minus 1. That's why this sequence is not convergent at t is equal to 1 and t is equal to 1 at t is equal to 2. Now you see t is equal to 2, what happened? fn2 equal to minus 1 to the power n into 2 to the power n, which is not convergent to, sequence fn2 is not convergent. तो ऐसा हो सकता है कि सीक्वेंस ऑफ फंक्शन अगर दिया हुआ है तो कुछ पॉइंट पर कन्वर्जेंट कर सकता है और कुछ पॉइंट पर कन्वर्जेंट नहीं भी कर सकता. इफ sequence f and t convergent each point of t belongs to t, then sequence is called pointwise convergent. If there exists at least one point where the function is not convergent, then sequence is not pointwise convergent. If convergent at every point of t belongs to t, then sequence is pointwise convergent. अब हम लोग एक नोट से देखते हैं. नोट, in case if sequence f and t n is equal to 1 to infinity converge for all t belongs to t, okay, then we say sequence fn converges pointwise, otherwise no. If there exists at least one point where the sequence of function is not convergent, then we can't say sequence is convergent, pointwise convergent. If every point, if we select any points of the domain and sequence is convergent, then we only say sequence is pointwise convergent. For any t belongs to t, limit of f and t at t tending to infinity, as n tending to infinity, lt, says another note. For any t belongs to d, limit of n tending to infinity fn t equal to lt. That means how to define the limit? You already know the epsilon delta definition of a limit. That is, for any epsilon positive, there exists and depends on the epsilon and t belongs to natural number such that mod of fnt minus lt less than epsilon for all n greater than equal to n epsilon t. N depends on the epsilon and t. For any t belongs to d, limit of fn t is lt, then sequence is said to be pointwise convergent. Then sequence is said to be pointwise convergent. Now define. Now we want to change the color. Okay. Now define a function from f is a function from d to r such that f of t equal to limit of n tending to infinity fnt. This limit is said to be pointwise limit, and this is lt. This is lt for all t belongs to d. Here f is well defined. Here f is well defined because f of t is equal to limit of n tending to infinity fn t is equal to lt, which is already defined. So f is well defined. Let fn is a sequence of be a sequence of function defined on d, and f is a function defined on d Now you want to define the pointwise convergent. Okay, if for any epsilon positive there exists an epsilon t belongs to natural number such that mod of fn t minus f of t is less than epsilon for all n greater than equal to n epsilon t. Then we say sequence is pointwise convergent. Then we say sequence fn t converge pointwise. To f of t. Okay, that means limit of fn t equal to limit of n tending to infinity fn t is equal to f of t. That is, any notation we also represent as notation for pointwise convergence. Fn convergent to f pointwise for pointwise convergent. Now see the notes. Okay. If there exists at least one point where the sequence of function we already study, but now we write in the notes. Okay. That's why you can anytime you can recall and note. If there exists at least one point T naught belongs to T such that limit of n tending to infinity Fn T naught does not exist. क्या अगर एग्जिस्ट नहीं करता है then we say sequence Fn T does not converge pointwise on the sequence point does not converge pointwise on D. Now see the example. Example Fn T equal to T to the power n. For all T belongs to closed interval 0, 1. Then pointwise limit will be pointwise limit f of t equal to what? When t equal to 0, then 0. T belongs to open 0 to 1. This also 0. And 1 at t equal to 1. This will be 0 at t belongs to close 0 open at 1 and 1 at t equal to 1. This sequence is convergent at every point of t belongs to D. D means close interval 0, 1. That means this sequence is pointwise convergent. Sequence, that means here sequence f and t is a pointwise convergent. Here sequence f and t is a pointwise convergent to f. This is notation for pointwise convergence. Now see the another example. Example number 1. Example number 2. Fn t equal to t to the power n by n factorial for all t belongs to closed interval 0, 1. Then Fn t goes to 0 for all t belongs to closed interval 0, 1. This is f of t. That means sequence Fn t is pointwise convergent to f of t, which is equal to 0 for all t belongs to closed interval 0, 1. This sequence is pointwise convergent. In first example, this sequence Fn t is equal to t to the power n is pointwise convergent, and second example Fn t equal to t to the power n but n factorial is also pointwise convergent. Now see on the next example. Example number 3. Fn t equal to sin nt. t belongs to closed interval 0, pi. Let t is equal to 1 by 2. Now see what happens. If you put t is equal to 1 by 2, t is equal to pi by 2. Fn pi by 2 equal to sine of n pi by 2. And at sin n pi by 2, values of sin n pi by 2 may be 1, 0, 1, -1. Now see the sequence Fn pi by 2. At n is equal to 1, sin pi by 2, values of sin pi by 2 is 1. N is equal to 2, sin pi, and n equal to 2, sin pi, at sin pi is 0. N is equal to 3, sin 3 pi by 2, sin 3 pi by 2 -1, and so on. And sin 2 pi is 0. This sequence Fn pi by 2 has 3 limit points, 1, -1, and 0. And we already know if sequence has more than one limit point, then sequence is not convergent. Actually, this sequence Fn pi by 2 is a sequence of real number. Okay, so this sequence is a sequence of real number and it has 3 limit points. Then obviously this sequence is not convergent. That means there we can say that the sequence Fn t is not pointwise convergent. Is not pointwise convergent. On 0 to pi, because pi by 2 belongs to 0 is in this interval 0 to pi. Okay, thank you.